Welcome to The Explainer. Today we're going to talk about something that is, no joke, one of the biggest and highest impact optimizations you can make for your LLM applications. We're talking about prompt caching. So let me just start with a question. Imagine you give an LLM a huge document, and then you want to ask a bunch of questions about it. Does it make any sense at all to pay for that model to reread the entire document every single time you ask a new question? Of course not, right? Well, that's exactly the problem we're going to solve today. All right, let's get into it. Here's what we're covering. First, we'll dig into what I call the repetition tax. Then we'll talk about the solution, which honestly feels like a free lunch. We'll peek under the hood to see how it works and get super practical on how to maximize your cache hits. We'll also see how this fits into a bigger caching layer cake, and finally, cover how to make sure it's actually working and what your return on investment is. So let's kick things off with the core problem. The thing that almost every single LLM application runs into. Let's call it the LLM repetition tax. Okay, so here's the deal. Every time you send the same big chunk of text, your system prompt, all those tool definitions, a giant PDF you've uploaded, you're forcing the model to do the same work over and over again. It has to reread and reprocess all those same tokens. And that redundant work costs you. It costs you in time, which means higher latency for your users, and it costs you in money, which means a higher bill for you. Okay, enough about the problem. Let's talk about the solution. And this is the part that honestly feels almost too good to be true. It's a feature built right into the model provider's systems that makes your calls way faster and way cheaper. So what is prompt caching? In a nutshell, it lets the model remember the first part of your prompt, the static, unchanging part. It basically says, hey, wait a minute, I've seen this before. Let me just load up my memory of it, and I can start processing right from where the new stuff begins. And the impact? It's huge. For prompts that have these big, repetitive beginnings, you can see your time to first token, which is a really key measure of how fast your app feels, drop by as much as 80%. That is a massive improvement to the user experience. And then there's the money, and this is where it gets really incredible. Since the model isn't reprocessing all those initial tokens, you're not paying for them. In the right situations, you can literally eliminate up to 90% of your input token costs. Now, this is a really, really important point. We need to be clear about what's being cached. Prompt caching saves the model's computation, its internal brain state, if you will, not the final text answer. This means the model still generates a totally fresh, unique response to your new question every single time. It just does it a whole lot faster. So how does this actually work? Let's pop the hood for a second and see how the system decides whether to use that cache or just start from scratch. It's a pretty logical process, but the secret is all in the details. Okay, so here's the four-step dance. Your request comes in, the API hashes it and sends it to a server that might have a match. Then it looks for that match. If it finds one, boom, cache hit. The model loads the state and gets to work. If not, it's a cache miss. But the cool part is, it then processes the full prompt and stores that prefix for the next time. But the whole game is won or lost in step 2. I really can't say this enough. The matching has to be perfect. We are talking exact, byte-for-byte identical. A single extra space you can't even see, having your JSON keys in a different order, a timestamp that changes by a millisecond. Any of that will break the cache and cause a miss. It is that strict. Precision is absolutely everything. Okay, so we know it has to be perfect. So how do we make it perfect? Let's get into the practical how-to side of things and talk about structuring your prompts to get as many of those cache hits as possible. This right here is the mantra. If you remember only one thing from this whole explainer, let it be this: static first, dynamic last. Everything that stays the same goes at the beginning. Everything that changes goes at the very, very end. So you want to build your prompt like a layer cake in a consistent, predictable order. You start with your system prompt. Then you add your tool definitions. After that, you layer in any big documents or examples. And only then, at the absolute bottom, do you stick the part that's different every time, the user's actual question. This gives you the biggest possible static prefix to cache. Now, something you've got to know is that the big providers all handle this a little differently. OpenAI, for example, is mostly automatic. It just kicks in for bigger prompts. Claude gives you more fine-grained control with special tags, and Gemini has both automatic and explicit options, where you can even set how long the cache should live, its time to live. And as you can see, you have to look for a specific metric in the API response, like cached tokens, to actually confirm that it's working. All right, so prompt caching is awesome, but it's actually just one layer in a bigger caching cake. It's a super powerful tool, but it isn't the only kind of caching you should be thinking about. This chart just nails the difference. Prompt caching, which we've been talking about, needs that exact prefix match to cache the model's internal state. It's all about making the LLM think faster. Semantic caching is different. It looks for similar meaning in the user's question, and it caches the final answer. Its goal is to avoid needing the LLM to think at all. So the pro move? You use both. It's a double caching strategy. First, your application checks its semantic cache. It asks, hey, have I answered a question that means the same thing as this one before? This is a lifesaver for things like customer support bots. If the answer is yes, bam, you return the cached answer. Done. No LLM call needed. If it's a totally new question, okay, fine, we call the LLM, but we do it with our perfectly structured prompt to get that sweet, sweet prompt cache hit. So you've set this all up, it's running. How do you actually know if it's, working? You can't just set it and forget it. You've got to measure and be ready to troubleshoot. You can't improve what you don't measure, right? So you've got to be your own detective. Here's your checklist. What's your cache hit rate? Are you seeing that latency drop? How much money are you actually saving? This is the data that proves the value of your work and shows you where you can optimize even more. And if those numbers don't look good, don't panic. It's usually one of a few common culprits. If you're getting 0 hits, you need to log your actual prompts and find those tiny byte-level differences. If you notice small changes are breaking the cache, you've got some dynamic data hiding in there that you need to find and remove. And if it seems to be forgetting too quickly, you might be hitting the provider's time to live limit, and you may need to look for longer retention options. So let's just wrap this up with the big idea here. Prompt caching is one of the highest return on investment things you can do. It's a low-effort way to directly improve your costs and your user experience. You get faster responses, you get lower bills, and you do it all without changing the quality of the model's output one bit. It really is a win-win. So I'll leave you with this final thought. Now that you know how to make your AI applications significantly faster and cheaper, what does that unlock for you? What new features can you now afford to build? What new products can you create? The savings aren't just a number on a bill, they're an opportunity.